Okay. Can you see?
Yep. But it will be great if you can put it to full screen.
Slide.
Yeah. Okay. Hey.
Can you
Okay.
see it?
Yes. Very clear. Good.
Okay. Are the students ready?
Yep. I think so.
Yeah.
Yeah.
Okay. Assalamualaikum warahmatullahi wabarakatuh, and very good morning to Architect Wailai and all students. I don't know how many of you are non-Malay speaking students. I mean,
Only
from
one.
overseas. Only one.
Only one.
Only one from.
Maldives. Another two from Indonesia, but I think they can't pick up
Oh, they
Malay.
can't pick up because they are too far.
Yeah.
Okay.
I mean, they can pick up Malay. I think if you want. Only
Oh,
one.
yeah, they can pick up Malay. Yeah,
Yeah.
because I have some joke in Malay, which I don't think
We try
our
to
friend
translate.
joke normally is not translatable.
True.
But
True.
anyway, I was only joking. I just want to know how many of you
Only
are
one. Only
Malay
one.
speaking.
Yeah.
Yeah, only one.
From.
It's okay.
Okay.
Okay. First of all, thank you, Architect Walai, for having me here, and thank you for everybody for your presence. I was given a task by Architect Walai to give a talk on medium span structure. Actually, I was wondering exactly the medium span structure, in your context. Because when we talk about giving a lecture on medium span structure, I don't think one lecture will be sufficient because medium span structure includes almost everything, especially in the context of building in your context, even you are in second year, you have to look at so many things, various aspects of the structure. However, I try to be selective and try to focus on things that are relevant to you and applicable to you. But you have to really follow the presentation, follow my talk, because I will be jumping from here to there, from one context to another context, because construction is normally related to many other things, related to your design, related to culture, climate, and so on and so forth. So I hope you can bear with me. I hope you can follow my sharing today. Okay, if you are ready, I can start now. Medium span structure, which is, as I said, very large. Uh, First of all, I think we need to identify, we need to understand the definition of building span. I know you are doing something to do with medium span structure, and in fact, the third year is also dealing with medium span structure. Then before you go further, I think you need to know what is meant by medium span structure. So here I try to look at building span in two different categories, but they are related. One is the span of the roof structure. That is what we normally refer to. The span of the roof structure over a space without any support in between, meaning that the roof has no support, and in between the space there is or there are no support. So the roof is covering an open and columnless space. So that is one definition of building span. So you will look at the details of the categories later. And secondly, the span is also referring to building space, the spaces that the roof are covering, because the ability of the roof to cover the space is different between the spanning of the space. I'm relating it to columns, from column to column. So column to column spanning, the ability is different from the ability of roof structure covering the space. The space might have more than one sets of columns, um, but the columns themselves, they might have underneath different sets of beams. I hope you can understand what I mean. The space may be empty, but the support of the space underneath, under the floor, could have more than one set of beams. So therefore, the two definition, or the two categories are different. You may be confused now, but never mind. Later you will see the difference between the two. All right. For your information, I have more than 50 slides. I'm not sure if I can finish. I think I'm given only 1 hour, isn't it?
We
Yeah.
could do 1 to 1.5.
Yeah, 1 to 1.5, including question. It depends on your alertness, and whether you still be with me after the 1 hour. Sometimes the lecture
Understand.
is too boring, so you don't want to stay longer. So with this system, where you can switch off the video, you can go to sleep anyway. Okay. Now, this table shows the definition, or the definition of uh, building span based on timber roof. Um, Timber roof, I got the information from an article, so I can easily share with you. I do not have directly the definition based on steel roof, but I still, hopefully I can share with you something on steel roofing material. But timber roof is this one. If you look at the table, there are three different spanning definition: simple span, medium span, and long span. So you are dealing with the one in the middle, which is the medium span. Let me go to the simple span first. It is between 2 to 8 meters, less than 8 meters. 3 to 7.5, 7.9. This is known as, or categorized as, simple span. Okay. So when we talk about medium span, the second one, which is ranging from 8 to 20 meters. So if you have a roof spanning without any support underneath the roof structure, so you call it a medium span structure, okay, a medium span project. So I think you need at least one room to have, or one space to have, sorry, to have this type of spanning. And then another one is long span. I don't think you'll be dealing with this. Maybe when you go to the master's level, you may have the opportunity to go for this, which is over 20 meters. Um, you may be dealing with stadiums, arena, or factories. So for this level of your study, I think the largest that you go is the medium span. And even that, I think very little, or I think not many, or none of our previous students had any span up to 24 meters, at least my students. Maybe, I don't know, maybe architects wildlife student, you have maybe experience them having more than 8 meters, or maybe 24 meters, I don't know. Okay, so if you look at the spanning, the definition of the different span, uh, those spanning are associated with the type of structural system. I think this is important so that you know when you select when you selected the spanning medium, simple, or long span, you know what are the appropriate roof system. In this case, timber roof system or a timber roof structure. Okay, for simple span, the structure can be a simple truss and also simple not post and beam, rafter. We'll look at it later. But also include for even a simple span, the span also suggesting more sophisticated uh, structural system applicable to this spanning, including laminated beam, box beam, trusses, and straight beam in this is maybe related to a flat roof, straight beams, and these are the options that you can have in terms of timber structure for the roof. And medium span, I think when a span is beyond 8 meters. So for your information, beyond 8 meters, normally, but not necessarily, roof structure requiring trusses or arches or space frame or pyramid shaped structure. I think many of these you have came across, you have seen, and folded plate and also laminated rigid structure. I think I'll show you some of the pictures. And if you look at long span, also having more or less the same structural options, trusses, laminated arches, space frame again, curved ribs and shell. These are all in timber. Now, the only things that you need to do is actually as an architect, you don't involve in calculating the sizes of the structural system. You need to select the forms of the structural system, the material, and based on the rule of thumb. Normally, we base on rule of thumbs. If there are rule of thumbs given, so you base your decision on the sizes, the spanning, the types on the rule of thumbs. I can share with you some, but I'm not going to go into very detail because I don't think 1.5 hours would be enough for that. I try to keep it as brief, but in the form of design tips, which you can use in your design exercise. Okay. Any questions so far with respect to this? So now you know what is actually a medium span structure. Anything less than 8 meters is not considered as medium span structure. Looking at the roof covering perspective. Okay, so all right, then I can proceed. Okay, this is actually derived from a literature, sorry, trade literature. I think a brochure from Gang Nails Company. I think if you don't know what gang nail is, you can just browse in the internet gang nail. Gang nail is a type of connector to connect members of the roof structure, the timber. So it's known as gang nail. But it becomes, a standard frame maker or manufacturer. So they give this guide, and actually, I also use this guide to inform the student. If you look at the first triangle, the first roof, the first rafter, roof truss, not roof truss, the first roof system, the topmost, that is actually what we call rafter with a tie. Oh, sorry, a tie. If you look at, if you can see my cursor here, can you see my cursor? This is a tie. Okay, so beyond 2.8, actually 3 meters. Beyond 3 meters, actually you need only these two rafters. You need only these two rafters. Okay, you don't need the tie. But when you reach 3 meters, or in this case 2.8 meters, then you start to need what we call a tie here. Tie, or the member is in tension. Okay, this roof member is in tension. So therefore, the tie can be in the form of timber. Actually, if you notice, some method is not using timber, it's using cable, steel cable. You can use steel cable because the tendency is that this member is subjected to tension. So you can use timber, or you can use steel cable or wire. Okay, so meaning that below less than 2.8, you can have without the tie. Okay, when you look at the second one here, 4 meters. Here, 4 meters actually uh, slightly larger spanning, in which you need the tie, and also you need a strut here, compression. This is also a member of the truss. You don't call it a truss yet. Okay. Um, you call this one tie and strut. Okay, you have, this is very common in the traditional method. Some of the traditional method even use this system for more than 4 meters. But remember, the sizes of the members are quite large. So therefore, this type of structural system, timber structural system, can be used. If you go further, so the third picture, the third triangle here, the third truss here, this is what we call a roof truss, or trussed roof. Okay, in which you have the tie. Sorry, my cursor isn't working well. Okay, you can see, if you can see my cursor, you have this tie, which is in tension. This one is also in tension, and this is in compression. This is what we call strut. So you can see this is actually what we call truss roof. And truss roof is applied, is normally needed for spanning 6 meters and above. Okay, so you can see the two options below are for a larger spanning, which is 9 meters to 11 meters. So you can see timber truss roof for this kind of trusses can span up to 11 meters. So if you have a span for 11 meters, you have you can use this option. Okay, so you can see the trusses are ranging from spanning of 6 meters up to 11 meters. Can timber structure, roof structure span for more than 11 meters? Yes, but using different types of materials or system. Okay, if you notice in the table, even at the simple spanning, there is a material of timber using known as glue laminated. Actually, glue, Glue, laminated mean it is actually a lamination of timber. We have it in Malaysia, and this is actually quite commonly used. And these are a manufactured timber. This is not original timber or natural timber. This is manufactured timber with larger sizes and with larger capacity, higher capacity in spanning the span. If you look at this one, glue laminated timber for roof structure, it can cover from 3 meters to over 10 meters. I'm saying over 10 meters. For building, this could be the common one, from 3 meters to 10 meters. But other application, if you are talking about larger building time and also civil engineering work, we have seen glue laminated timber is spanning for 50 meters. Can you imagine 50 meters? Um, I cannot give you any direct example of hand. It is a very large span, but for building, you normally use them uh, for between 3 to 10 meters. Less than 3 meters may not be appropriate to use glue laminated timber because it defeats the purpose of being a very strong structure to cover just a small span. So, but you can go for beyond 10 meters. Why it is 3 to 10 meters? Because, 10 meters, it indicates that you need thicker members of the structure. Then it will affect your headroom. So therefore, if you have a longer spanning, you tend to have thicker beams, and that will take your headrooms, your floor-to-floor height. So therefore, the typical span is around 3 to 10 meters. Some other school of thought might suggest 11 meters or even more. Okay, any questions so far? Then I can proceed. Okay, this is if you want to use glue lamp techniques. This is I think, if not mistaken, this is Malaysian glue lamp products. I took it from an article. Okay, for this one, the typical span is between 6 to 12 meters. If you want to use glue lamp in this, based on this suggestion, it shouldn't be less than 5 meters. Otherwise, it would be economical. Though earlier I mentioned some school of thought they might allow 3 to 10 meters, but in this case, this is a Malaysian context. The suggestion for typical spanning is between 6 to 12 meters. So you can have a glue lamp if your building is spanning for 12 meters. As I said, can I span for more than 12 meters using glue lamp? Yes, you can, but you need a different design. And you see that the depths here. If you look at the depth, the 12 meters, the depths mean the height of the beam is about 600 mm. Can you imagine the depths? 600 mm, which is more than half a meter. So that is why the typical span is actually reflecting the appropriateness of the sizes of the beams with the spaces and with the building. Maybe if you are designing for an arena, for example, a stadium, yes, a stadium can be made using timber structure, glue lamp. But for a stadium with a very high volume, for more than 12 meters is possible because the depths will not be an issue. Okay. The next one is plywood box. That is another timber roofing system. Not only roofing system. In this case, it can also be used for the building, the beams, and also the roof structure. If you look at the size here, the spanning that is allowable, recommended or typical span for box beam. In this case, this is actually box beam. It is a beam made of plywood. Plywood is formed into boxes, and these boxes are acting as beam. But you must remember these are not empty boxes. Underneath, inside it, there are structural bracing inside. So it looks clean outside, but inside there are bracing. So plywood box is considered as one piece. It is lighter. It is also very strong. And it can span from 4 meters to 7.4 meters. So meaning that you can go for 4 meters. You can go for 3 meters if you like, but 3 meters may not be advisable for economic reasons. So 4 to 7.5 meters would be a good spanning for plywood box roof system. Of course, this is truss roof. I'm showing you the beautiful one, the beautifully created, composed. If you want to expose the structure of the roof, the timber, this is one of the techniques which you can use. The span for truss roof, as I indicated much earlier in one of my earlier slides, is between 6 to 11 meters. It may not be economical if you use trusses for less than 6 meters. And you can use trusses for more than 11 meters. But as I said, the size would be colossal, would be big. Okay, so the typical span is between 6 to 11 meters. Timber space frame. This is an interesting example of timber space frame. You know, timber space frame. Normally, you might have seen a space frame made of steel, and there are a timber space frame, and it can cover as large as the steel space frame, and it is more um, aesthetically pleasant. You can see here in this picture. You can see beautifully composed or constructed timber space frame. The color scheme can be changed if you like. I can imagine mine. I wouldn't go for this color. I would go for striking red color, for example, to make the space more vibrant and and active. This is my personal. What I was trying to express here, the roof structure itself is giving a lot of meaning to your space. It gives more excitement to your space. And besides this its ability to span. If you notice, I don't put any indication of the spanning. I'm not sure. I think I have indicated in different slides. I couldn't find any clear definition of this roof system, which is timber space frame, in terms of the spanning. I think in this slide, you can see another option of timber space frame, which can go up to 18 meters. In fact, the earlier one can go up to 18 meters. It is that I cannot imagine, because I'm not a civil engineer. 18 meters implies the depth of the structure. And the depth of the structure implies the need for the headroom for floor-to-floor height. So the larger the distance, the span, the thicker the members of the roof, and it implies the need for a higher height for your room, for the space. Okay, but for timber space frame, I have found up to 18 meters has been used. So if you have 15 meters, I think it's nothing, it is very commonly used. But I think you can also use the rule of thumb for trusses, for normal trusses, which is from 6 to 11 meters. So 6 to 11 meters for a timber space frame is conveniently sufficient, appropriate. Okay. This is another form of roof structure, which is also made of timber, but I am not sure whether it is appropriate for our country. I think we can, but we need to cover uh, the the roof with waterproof agent, with waterproof materials. You may need maybe metal finishes, maybe copper, or maybe architect while I have seen any of this in the practice. But this is one of the option of the roof structure system. That is known as timber folded plate. Normally, folded plates are made of concrete because concretes are easily cast. You know, concrete is a very plastic material before it is hardened, so you can form it into any form, including this form. With timber, it tends to be less fluid, less flexible compared to concrete because timber tend to be a modular material. You know, it comes with a rigid material as a rigid material. So therefore, you have limited ability of usage. But in this case, for roofing, this is an interesting option as folded plate. I think this is made of plywood, not plain natural timber, but this one is a manufactured timber, which is a plywood. I think this is a folded plate roof made of plywood. And arches. One of the options of glue laminated timber is making arches. So if you look at this one, I have seen this kind of glue lamp arches has been used in civil engineering in bridge building up to 50 meter span, as I mentioned earlier. So, so you don't need to worry now. Timber can be spanning a long span. You just need to know what are the system and you know what are the options that you have. As I said, your options for building may not be up to 50 meter spanning. I repeat, because of the requirement of the beams, the depths of the beams, which may affect the height or the floor to floor height. So therefore, you have some kind of typical span, which is much less than 50 meters. This is for building. Okay, this example, the picture is for building, but the spanning that I mentioned below here is for the span. The 50 meters is not for building, you know, to house people, but for civil engineering structure. Okay, I have some information which I can share with you. To be honest to you, a good reference is um, there is a book, Time Saver. Time savers. There is one. I can't remember the detail of the time savers. I have a book with me. Unfortunately, I'm not able to. No, I'm able to pick up, but there are so many things for me to briefly describe what is explained in the book. I think it will be very lengthy. I try to keep the lecture simpler and easy for you to understand, to grasp. If you like, you can go to time savers. There are many versions. There are many categories in time savers. One of them, if I'm not mistaken, environment and construction, something like that. Structure, construction, and environment. You can make a good reference to that when you want to refer to any requirement for steel roof structure. We are still dealing with roof structure. Okay, but anyway, these are some of the tips if you want to use steel as your roof structure. The range of the span for steel roof structure is between 3 meters to 90 meters. Uh, when you talk about 90 meters, actually we are referring to beyond a building spanning. I think this is about maybe referring to bridges and also civil engineering or large building structure like stadium and whatnot. Okay, but minimum is 3 meters. I think less than 3 meters, yeah, I've seen buildings with less than 3 meters using steel, but we consider them as uneconomical. As I said, you can use also timber, but you can also use steel. But if you spend, if you want to use steel, it should be larger than 3 meters and should be less than 90 meters. For building, I think the suggestion is less than, I can't remember. Sorry, the figure I think is more or less the same, 3 to 12 meters. Okay, that is a good span even for steel. You can go for beyond 12 meters, yes, but you need proper reference, proper referencing. The good example, because I couldn't get the rule of thumb. I have seen some articles. I can share with you some articles helping you uh, to understand the span and also the structural system required. This is referring to steel roof structure. It sounds a little bit more engineering. If you are interested in that, I think there is an article. I have the article with me. You can come back to me and ask for it. I'll give you. Okay, and a slope of 22 degrees is common for corrugated steel and asbestos roofing sheet. This is another common guide. If you use steel structure, of course, you have steel structure for flat roof, which is less than 10 degrees, 10 degrees or less. But commonly, effectively, a good gradient, a slope for a roof made of steel structure is 22 degrees. Okay, if you are using metal decking or asbestos, we are not using asbestos anymore. I think I still remember 10 or 15 years ago, we had been instructed by the country for not using asbestos. I think this is taken from different countries. We are no longer using asbestos. Instead, we use asbestos-free. Maybe Architect Wailai is aware of the current development of the use of asbestos as roofing sheet. This is actually both are similar because they are sheets roof, and they don't need actually a very steep angle, but to be effective for strength and durability, I think there are two things which you need to understand. If you are civil engineers, you need to understand two things. One is the strength. The other one is durability. Durability is actually ability to withstand the external agent, the weather, water stripping through into the building because you have very low degree of angle, for example. You may have problem in channeling the water, especially when we have pouring rain in this country. So therefore, of course, yes, there are flat roof using steel, many actually, for less than 10 degree angle, but for a more effective application, you need 22 degrees gradient for the roof structure. Okay, and space frame here, space frame, for steel space frame, I've mentioned earlier related to timber space frame. For steel space frame, you can have your spanning, between 22 to 33 meters. But 22 is not minimum. Space frame can go less than this. Okay, 6 meters, 12 meters, But effectively, economically, if you have 22 meters, that would be a good spanning for metal space frame. Okay, but this is not actually the limit. This is the typical span if you are using metal space frame. If you are using timber space frame, please refer to my earlier notes. Right, I think these are some of the shape of the metal roof and the suitability to the spanning. If you look at this one, this is a truss roof made of steel. All right, so you can see for span um, less than 7 meters, or 7 meters or less, you have this kind of truss system. Okay, and if you go between 7 to 11 meters, this is the time of steel truss that you can use. 17 to 24 meters, 25 meters, 11 to 17 meters, okay, 25 to 31 meters. You can see these are the options that you can select. Okay, when you are selecting, when you use steel trusses for your building, for your project. So if you are using 8 meter spanning, for example, the second option would be appropriate. Okay. Okay, steel space frame up to 33 meters. Okay, so you can see this is if you notice some of the swimming pool, a public swimming pool where you have a large opening uninterrupted by columns. So they normally use space frame and steel space frame tend to be lighter, tend to be stronger, and it span larger spanning. Okay. I will not explain to you the very detail because I don't think we have the time to go into very detail. Okay, I hope you can start selecting any suitable structural system, roof structural system for your building. All right, I think I have briefly covered the spanning defined in terms of the roof structure. And I covered more or less on timber roof structure and also steel roof structure. I hope this helps. Now we go into the second categories, which is building span, which is based on the space of the building. We are referring to concrete structure. We are referring to column span. But I think mostly in this presentation, I'll be talking about the floor system, because for concrete structure, floor system play an important role, because the floor system, it affect the distribution of the loading. Hence, it affect the planning or the design of the beams, and also the design of the overall structural system. For today, I will only covering structural system based on skeletal structure, posts and beams. I am not covering other system. I'm not covering on tensile structure. I'm not covering on shell structure, and there are also tent structure. I'm not covering that. I am only covering concrete structure based on post and beam or skeletal structure. That would be more relevant to what you are handling now. I'm not covering even the load-bearing wall structure. Although I have a lot of notes on this, but I'm not going to cover because I think that is going to be a lot, and we don't have the time, unless if you want to maybe next time you want to know something about load bearing structure, we can discuss about that one later. Okay, this is building span based on concrete structure. Now, referring to span to, the span of building, this is based on the column beam to beam structural system. Okay, and also divided in categorized into three categories: simple span, medium span, and long span. The simple span uh, is any span less than 6 meters is considered as simple span, and also known as economical span, anything less than 6 meters. Okay, so the concrete system, uh, sorry guys, okay, never mind. Typical span system, okay, typical structural system, building span, dimension, and again typical structure system. Okay, for less than 6 meters, you can use simple one-way or two-way concrete slab. Okay, and also beamless slab. For your information, beamless slab is the span for a beamless slab is ranging from 3 to 8 meters. This is a typical span for beamless slab. Anyone of you have seen beamless slab before? Anyone? Can you just say yes or no, so that I can see the indication? Anyone of you knows what is a beamless slab? Have you learned beamless slab? Can I hear any answer from you?
I think they haven't yet.
They haven't yet.
Yeah,
Okay.
they haven't learned that yet.
Okay. They haven't yet know what is a beamless slab. Okay.
They have recently heard the barber deck. But other
Yeah,
than
that
that,
is also beamless slab, but it
yeah,
is actually the most current and most sophisticated for large span. I think
yeah,
I would like to share the basic beamless slab
yeah.
system.
That's will be great.
Yeah. All right. So there are two options here for simple span. For span less than 6 meters, you don't have to go for more sophisticated floor system or construction system. You can just go to a normal one-way or two-way slab, the one that you can see in our studios. You are not in the studios, are you? Okay, and beamless slab, I'll show you some pictures on beamless slab. Okay, the second one is medium span, which is between 6 to 9 meters. 6 to 9 meters. 6 to 9 meters is considered is medium span. Remember, the roof spanning is medium span is referring to the span ranging from 8 to 24 meters, but not for concrete structure. For concrete structure, medium span is between 6 to 9 meters. So in this case, you can also use concrete slab, the normal concrete slab, one-way or two-way system concrete slab. I'll show you what is a one-way slab, what is a two-way slab in architectural perspective, not in engineering perspective. And also, this system, this span can also use beamless slab. As I said, similar to the simple span, you can use beamless slab between 3 to 8 meters. You can see beamless slab can be used for simple span and also medium span. Okay. Or 10 meters for pre-stressed concrete. I'm not sure whether you have heard pre-stressed concrete. Can anyone say, have you heard what is a pre-stressed concrete?
No.
No, okay. Oh, okay. You are in the second year. You haven't learned what is pre-stressed concrete. Okay.
They are in my they actually the structure too has we reshuffle it, so they are learning it now under me, but we haven't reached that yet.
Oh, okay, okay, okay. So you'll be learning that. If we have the time, I can share with you the analogy of pre-stressed concrete.
Yeah, that would be good
Yeah,
too.
because pre-stressed concrete is actually a different. It's also made of concrete with reinforcement, but in a different application. Okay, and also rib slab, a waffle slab. These two are considered as specially formed slab, waffle slab and rib slab. Uh, oh, sorry, no, rib slab is different. Waffle slab and the other type of slab which I haven't mentioned here is trough, Trough. Both are considered as specially cast. It's a kind of specialized floor system. Rib slab, they are more or less related, but they are very much designed by architects. The rib is not pre-designed. Waffle is pre-designed. Rib is designed by the architect, the form of the rib. If you go to underneath the mosque, masjid, any one of you have been to the mosque? Underneath the mosque, the lowest level where you had your exam. If you look up, you see rib slab, with diagonal beams. Uh, those are rib slab. Okay. Band beams or horizontal slab. I will show you some example of band beam or horizontal slab. Not horizontal slab. I think not the slab. The word should be horizontal beam. Sorry, my mistake. Beg your pardon. And also pre-stressed concrete can also use for span 8 meters and above. That is about medium span. Okay, when you are dealing with the span between 6 to 9 meters, I think these are the suggestions that you can use. They are the options that are safe for you to use. But still, you need guides to use them. You can use simply spanning beam slab. You can use beamless slab, including bubble decks. I think you have seen bubble decks. You can use rib slab, waffle slab, and band beams, horizontal beams, and also you can use pre-stressed concrete slab. This is for medium span slab, medium span structure, the floor system between 6 to 9 meters. What about the long span slab, which is from 9 to 16 meters? Um, for concrete structure, if you notice 16 meters considered for the normal building, 16 meters considered the longer spanning, not because concrete cannot go for longer span. You can go for, as I said, even 20 meters. Okay, I have seen, if you're not mistaken, the bridge when I went to when I studied at Edinburgh. Sorry, not Edinburgh, Dundee. There is a bridge. Tay Bridge was I think the name of the bridge is a Tay Bridge because it is crossing the Tay River. If I'm not mistaken, the span of that bridge from column to column is a quarter of kilometer, 250 meters. So you can imagine if you are worrying whether your concrete structure can cover 10 meters, I think you can stop worrying now. But if you are covering for more than 60 meters, then you start to worry because, as I said, it is about the thickness and the effects of this thickness on the floor-to-floor height. Because when you have very thick slab, it will influence your beams, the thickness of the beams, and thickness of the beams is influencing the floor-to-floor height. That is what you should worry about, not the strength of the structure. But for long span structure, you may use rib slab, again, waffle slab, which is up to 16 meters, a band beam, and also pre-stressed concrete up to 60 meters. Okay, for your information, pre-stressed concrete, the floor, the beams can go beyond 60 meters. can go beyond, well beyond 16 meters. So you don't have to worry if you are designing for more than 16 meters. But for building, a normal building like the one you are dealing with, I don't think it should go for more than 16 meters. If you have a 16 meters span, then you need to break up the spanning into smaller than 16 meters. If you have 16 meters, why don't you divide into 8 meters apart so that you have 8 meters spanning? So you need not very thick floor and not very thick beams. As I said, I have a lot of materials. I may not be able to cover everything. Mungkin architect Walai can let me know if the time's up. I can keep talking, but I may be taking too much of your time. Okay, just let me know when and where I should stop. Okay, just to share with you structural system first. Roof, flat, uh, curve assemblies. This is about roof, floor. You have suspended floor. Okay, you have ground floor slab. I think these are all just to remind you of the basic structural system. I'm not actually my notes is also covering on the floor system, but not everything. I'm just covering. We are not covering yet the floor system. The support. Okay, the roof floors are supported by load-bearing walls. This is the thing which I mentioned. We are not covering this one. Load-bearing walls, roof and floor are supported on walls. This is covering of roof using load-bearing walls. I'm not sure whether you have learned this in your lecture, but this is also an option of the vertical support. For load-bearing wall system, if you are in JB, if you want to look at one of the a good example of load-bearing wall system, you go to Majlis Perbandaran Kulai. Okay, Majlis Perbandaran Kulai. That is actually one of the load-bearing wall system in Malaysia, which is designed by architect purposely for load-bearing wall by local architects. Column and beams, this is what we call skeletal structure. Columns only, this is the flat slab, the beamless floor. You have only column, you don't have the beam. Okay, this is actually the structural system. Option for your structural system, for your building, you have more or less three systems. This is not including the tensile structure, the tense structure, pneumatic structure. So we are not covering that. You will cover that one maybe in the upper years. Okay, floor system, you have two, suspended floor and ground floor slab. I'm not covering your ground floor slab. I hope I can cover a little bit on the suspended floor slab. Okay, ground floor slab. I think you know all this. I'm not going to cover this. Okay, just the rule of thumb, thickness of the ground floor slab, 100 for residential building, 100 mm thickness of the ground floor slab. And also the rest of the notes, I can give you the notes if you want later, or you can refer to the video if this lecture is recorded. Okay, I think these are, oh, sorry, I forgot to take out all these notes. You can take this one as a note. Never mind, I'm not going to cover this. So this is actually what I am trying to cover in this lecture. Suspended floor. Suspended floor, any floor that is using reinforcement above ground level. Also at ground level, there are suspended floors that are supported by the structural system. Okay, ground floor slab is supported by the by the ground. And the suspended floor is not supported by the ground. It is supported by the columns, and the loadings are brought to the foundation. You know, even at ground floor level, you may have suspended floor slab. Hello. Okay. Right. Sorry. Two-way span, one-way suspended floor slab. There are three options here: one-way spanning slab, two-way spanning slab, and beamless slab. These are the basic ones. Okay. What is one-way spanning slab? One-way spanning slab when one of the side is half or less than the longer side. For example, this one, the A side is half or less than half of B. That is what we use, the term that we normally refer to when we describe one-way spanning slab by the architects, by an architect. Well, in engineering definition, you can see the reinforcement are running from top to bottom, only one way. You don't have the crossing reinforcement. Okay. One-way slab, this is one-way slab. If you notice, this is one-way slab where you have two support here, and basically the support on the shorter sides do not require beams, but you can still see beam. Why do you see also beam? When you have post and beam structure, you need to brace or strengthen the columns. For bracing purposes, you need beam crossing from along the shorter sides. Okay, and two-way slab, you have both. I think two-way slab. What is two-way slab? Oh, sorry. Oh, I think I lost another one. For two-way slab, okay. I lost the uh, the diagram here for one two-way slab. Two-way spanning slab, the A is equal to B. A is more than half B or equal to B. Normally, it is A equal to B. So it is a squarish. The other one is rectangular. Okay, I hope you understand that. Yeah, this is a two-way slab. So you can see both sides are almost the same. Normally, tend to be the same. Or one side is half or larger. Okay, larger than half of B. Okay, I hope you can capture that. Okay, suspended floor slab. Okay, so sorry, simple one-way slab. We have already covered that one. And also one-way slab with band beam. What is band beam? Band beam is horizontal beam. Okay, you can, if you have the time, you can read the note. One of the importance of this band beam is to have shorter beam, not shorter beam, thinner, less depth. Okay, the beam is smaller, but it is wide. Okay, that is if you look at this diagram here. So the advantage is that you have large opening to accommodate services, horizontal services. This is the example. This is what we call band beam. Okay, band beam, the beam which is also known as horizontal beam. Okay, this is rib slab. For this rib slab, I think this is actually the form of rib slab, but actually this picture is referring to trough. Trough and rib slabs are the same. It's just that rib slab is designed separately, whereas trough is actually based on the manufactured formwork. So it is used for spanning between 6 to 12 meters. This is rib slab. Okay, if you can see, the arrow here is showing the rib, which is this is considered as one-way spanning slab. Okay, And this is also a rib slab. Okay, you can see here the rib. This is the rib, and this is the main beam. This is the rib, and then what is the advantage of having the rib slab? The advantage of having the rib slab is you can have thinner slab, concrete slab. So the concrete slab may not be very thick. You know, for a rib slab, you can bring down the thickness of the slab down to 75 mm, whereas the normal one minimum should be 100 mm or even more if you have a larger span. Okay, again, rib slab with band beam. You see band beam here, and you have rib slab there. And this is trough. This is, you see, band beam, sorry, rib slab and trough are the same. It's just that trough, it comes as a standard formwork. You can see the sizes of the formwork available for you to choose. And the thickness of the floor can be 75 mm. This is an example of, again, an example of trough. You notice rib slab and trough looks the same, but the difference is the way it is created. Suspended floor. This is actually the, sorry, I put it here. Two-way spanning slab. Okay, this is simple two-way spanning slab. Economic span 6 meters. You can use it for even less than 6 meters. And this is what we call waffle slab. Okay. Waffle slab for span between 6 meters to 12 meters. So there is a Malay word here. Okay, I hope you understand. Hingga is 2. Hingga means 2. 6 to 12 meters. All right. Waffle slab and trough or rib slabs are the same. It's just that waffle slab is a two-way version of the rib slab. So that you have squarish floor and you have waffle like the waffle that you eat. You know waffle. When you go to Daily Fresh, you order waffle with chocolate or with strawberry. That is waffle, and waffle also appears in floor system. But that is for 6 meters to 12 meters. Can you go beyond 12 meters? Yes, you can go beyond 12 meters, but you have to check the thickness, whether the thickness is sufficient, is appropriate to the floor-to-floor height. And this is, if you look at the diagram here, these are the standard sizes. If you use waffle slab, these are the standard sizes available: 600 mm, 800 mm, 900 mm, and 1.2 mm, which is 1.2 meters, with standard thickness of the floor that is 75 mm. Waffle slab with integral beams. You have waffle slab, and you have also band beam here. They call it integral beam. They are also known as band beam. Some school of thought, some group of people believe that waffle slab here is also considered as flat floor, beamless floor. But I don't use that definition. Okay, waffle slab and beamless floor is different. This is how waffle slab and also trough is made. It is a waffle slab. You have like cones here, a series of cones here, and trough you have like a trough. Yeah, it is like a channel, one piece here. But for waffle, it is just like how the waffle or the foot waffle is made. Okay, this is what we call waffle slab, and this is the formwork, standard formwork. Okay, this is the outcome. If you go to UTM administration building, the main building, Bangunan Chancellery, you will see, at the arrival spot there, if you look up to the ceiling, you will see waffle slab. One of the advantages of waffle slab is being beautiful, aesthetically pleasant. Okay, and then a different form of waffle slab. You can see waffle slab also applied at irregularly shaped space, but the waffle slab themselves need to be regularly shaped, but the floor itself can be irregularly shaped, provided at the point where the shape is not regular, you have to make it flat or flat slab. Okay. And this is another example of flat slab, sorry, waffle slab under a irregular shape floor. Okay, this is flat slab. If you never seen yet beamless or flat slab, I hope you can listen carefully. Okay, beamless slab is a slab without beam. It is supported by columns, but you can see the column has unique features. It has mushroom or capital, we call it. I'll show you later. And this is important. Thickness is between 225 to 300 mm. Even if you are using bubble deck, you tend to have more or less the same thickness, between 225 to 300. It's just that the bubble deck, you have the bubbles, made of polymer balls inside the slab. So it makes the slab lighter and stronger. So, but the basic beamless is the omission of the beam, but the thickness is much larger, than the normal floor. And the span, I think we have already covered, ranging from 3 meters to 9 meters. And the problem here is how to provide openings in between. Okay, so this is actually one of the drawbacks of using beamless. But normally beamless floor or flat slab is used for building requiring high headrooms to provide horizontal services, horizontal pipings or distribution pipes. Okay, flat slab simply you have the slab and you have the column. This is the features. The column capital or drop panel, we call it, both are the same. You need this drop capital or drop column drop panel. Why? Because you can imagine the shear stress happening between the edge of this column and the slab. So in order to reduce shear stress, you have to increase the width of the of the surface meeting between column and the floor slab. So to make it larger here, so it looks like a mushroom. You can see some of the project, including one of the project by Frank Wright or Lee Corbusier, I can't remember, having this kind of column with mushroom capital. Okay, so this is actually an important element if you are using beamless floor. Okay, this is the example. This is what we call column capital or mushroom. Okay, instead of drop panel, you can see it looks like a mushroom. It gives a larger area meeting the floor. The floor has no beams here. Okay, all right. So I'm not going to go through this one unless if we have time. I think this is actually some of the technique provided by CNCA, Concrete and Concrete and Cement and Concrete Association. I think used to be based in the UK. I think now there is a base in Australia. These are a method of selecting which floor system appropriate to your project. These are the points of consideration: fire, sound, small services, large services, major openings, horizontal services, soffit fixing, partition head, construction ease and speed, perimeter detailing. So if you want to select any of this type, you can choose here. You can see which one this system is good at. For example, this time one with spanning slab, good in fire, but not very good in terms of horizontal services. Okay, this is one example, and this is also this is for solid slab, and also I think this is also a two-way slab. And you can see one of the major disadvantages of this type of slab is poor horizontal services. It is not good. It is not supporting well the horizontal services. And also it is quite tedious, it's quite not problematic. It takes quite some time for construction speed. Okay, and for waffle slab, okay, you can see for fire it's poor, for SIME it's poor. The only advantages for waffle slab is when you need horizontal services. And another one which is not indicated here, it looks beautiful. Partition head is also difficult. If you want to have partition between spaces within the space, you cannot have a good partitioning. If you want to have the partition to reach the ceiling level, because you cannot fully cover. So therefore, for this type of construction, you may need flexible partition, only partition, which is collapsible partition, the lightweight partition. Okay, so it is only good in horizontal services. That you must remember, this is actually from the perspective of the engineers. All right. For flat slab, what is the most what is the major advantages of flat slab? All right. Fire protection is good, sound protection is good, small services is good, large services is not good. Major opening, you cannot have opening on the floor. That is what it's meant. You cannot simply have opening on the floor after it is constructed. You are going to disrupt the structural system. Okay, or even before it is constructed, you cannot simply have holes in between, because the only support is the floor and also the column. But the major advantages is also horizontal services. You have maximum space for your horizontal services, good for soffit fixing. Partitioning head is also good, and construction and ease and speed, I think it's also good. But perimeter detailing, for you to have walls on the perimeter is quite difficult because you don't have beam there. So you cannot have point loading there. So therefore, if you notice the pictures which I showed you, many of them are actually using lightweight partition, even at the edge. You have glass. You don't have much heavy walls on the perimeter of flat slab construction. I think I will stop here. I have another things to share with you, but I think it takes quite some time. I'm not going to. I just give this one to you. This is some of the methods of how can you estimate the sizes of the concrete structure. Okay, there are methods which I think I don't have sufficient teaching aids here to teach you how to calculate. If we are face-to-face meeting, so I can just share with you on the whiteboard. I think that's all I have. Architect Wildlife, sorry for taking so much of your time. If you have still have the time, I'm open to question and answer. Thank you.
Thank you so much, Dr. Mahmud. Very, very informative lecture input. And I'm sure the student might have a bit of problems for have a bit of question to ask. If you have any question, either they have some question to ask or they need more time to digest.
Obviously, I can understand that.
Yeah, it's a lot
this is a new lecture to them.
Yep.
Many of them are new, but I think you can go through back. If you record this one, you can go through again. If you want to have the slides, I can give you the slides later.
We'll appreciate that.
Yeah, so I can give you the slides
Yeah.
later.
Meanwhile, if you have any questions, you could ask here, ask through the chat box, so you can ask directly.
Can I stop sharing?
Yes, you
Yes.
could. I I I hear someone
Yeah,
asking
so that I
something.
can see the faces. There are 55. All of them are already here.
Hello,
Some
doctor. Am
Yeah.
I audible?
Yeah,
Okay.
we can
Yeah.
hear you.
Okay. I have a questions about the band beam. So, can you um, tell about what is the difference between the band beams between and conventional beam? So, which one is the most strongest one when you compare the both of it?
Okay. The question is, it is a good question, but I think you must understand both beams are should will be calculated by the structural engineer, and to be sufficient in terms of strength, to be able to withstand the strength. It is that the position of the beam is horizontal instead of vertical. Being horizontal, it has to be able to withstand the loading. But it is more, it is more, it provide more rooms for the horizontal services. So both have the same capacity. It's just that position of both are different, but both must be able to withstand. Actually, there is, as I said, there is a technique of identifying what is the minimum depth for bond beams. I don't have the table with you. The table is actually provided. If you can check in the internet, Cement and Concrete Association. I think now they have Australian base. There are guides, for designers, for architects, if you want to see. Okay, I hope I answer your question. Who was the one? Navin Kumar, is it?
Yep,
Yes,
Naveen
Kumar,
Kumar.
doctor.
are you okay?
Yeah.
Horizontal mean it is horizontal instead of vertical. Horizontal, so you have more space to run your horizontal services. But it has the same strength capacity.
Oh, okay, doctor. Yeah.
Okay.
Okay. Thank you, Naveen, and thank you, Kumar.
Okay,
Any
thank you.
other,
Any
any
other
other
question, or you
question?
are just about to digest? Is it too much? I think what I shared with you are basically basic.
Too many new terms.
Okay, too many new terms. Okay, I think I will.
Basic, but too many new terms.
I think what I shared with you are mostly design tips which you can use when selecting. You see,
Yeah.
I noticed many of the students, at least my student, they do not know what to select. They didn't understand. You see, like bubble deck, they didn't even know that bubble decks is a flat slab, and they
Mhm.
didn't know the flexibility of support for bubble deck. You can readjust, you can make the layout of your column creatively. Okay, so that is the thing that you need to optimize when you select any type of structural system. But I don't cover bubble deck here because I
Mhm.
think it is going to be quite complicated. I don't
Uh,
have the notes with me. That is the worst thing happened. But I
about
think if you can understand a flat slab, you will understand beamless slab.
Yeah. I actually given them a video which was recorded last semester where I invited the bubble deck specialist to
Yeah, yeah,
share about the system. So
yeah.
yeah, they are exposed to that.
Oh, that's good. I think that
Mhm.
is good. Then you have a good input. So luckily I didn't cover
Yeah.
it. Otherwise, I could have given you data from overseas instead of from Malaysia, which is not appropriate. Okay, so you have a good source of data
Okay.
information for you to look at. Yeah.
Okay. So student, I will take that no questions from the floor since no one asked any questions. So with that, we would like to thank Dr. Mahmud for this morning together with us for 1.5 hours to share on the basic of structure, which is very, very informative and very, very useful. Before we end the section, maybe the student just, could say say thank you to Dr. Mahmud for his time and his effort. Okay.
Okay, for your information,
Thank
I'll
you.
start my, sorry, I'll start my pre-retirement leave on Wednesday.
This Wednesday.
Yes, so
Oh,
I won't be seeing you, but
2 more
I'm still,
days.
yeah.
So this is
Yeah,
the last lecture input, is it?
yes, one of the last lecture input. Yeah, I still have
Okay.
not lecture input, some involvement in academic activities, but lecture input for the department, I think this is the last one.
Okay.
Maybe this is the last time you see my face here. Maybe
Oh.
I'll see, you will be able to see me later, but not in the lecture session like this. Okay, thank you.
Thank you so much.
Okay. I will give you the notes later after this, Architect Wildlife. So
Thank
with
you.
that, I have to leave you there. Okay.
Okay.
Allow me to leave you. Thank you. Bye-bye, everybody.
Thank you very much.
Thank you very much, Dr.
Thank you.
Okay, students, good to we have the last lecture input from Dr. Mahmud before he start his retirement. Okay, so anyway, we will have a 15-minute break. Okay, by 11:15, you could join to this UTM WebEx, and we will have another input lecture from me regarding services. Okay, so I see all of you later.